Have you ever thought why the cloud is so popular? Many people are talking about cloud. Actually, the cloud computing has existed around 20 years, but just gained popular use over the last few years. In fact, most people already use the cloud service just without realizing. Like the Gmail, Google Drive, and even the Facebook and Instagram are all cloud-based applications for the personal use. For the enterprise, for example, employees can access customers' information via the cloud-based CRM, like Salesforce, from their smartphones or iPad, at home, or while traveling, and can quickly share the information with others, anywhere, anytime. As you can see on this slide, according to a study by an international data group, 69% of the business are already using the cloud technology. Also, the big computer company Dell reports after they invested in cloud, enjoy up to 53% faster revenue growth than their competitors, because the cloud technology helps them for more efficiently run their organizations, better serve their customers, and dramatically increase their overall profit margins. Let's see what the benefits for using cloud. First of all, it can save the cost. As I mentioned, user can easily access to company and get the data anywhere, anytime. So it saves the cost of the time and money. Also, it can save the build-up cost, especially for the startup company, because most cloud service are pay-as-you-go. That means if you don't take advantage of what the cloud has to offer, then you don't have to dropping any money on it. Second, the cloud is more flexibility. For example, if you need extra bandwidth, a cloud-based service can meet the demand instantly, rather than undergoing a complex or expensive update to your IT infrastructure. And third, the cloud service allows mobile access to corporate data via cell phones, which you can consider now is over 2.6 billion smartphones are being used globally today. So it's a great way to ensure that no one is ever left out of the loop. And then with the information stored in the cloud, you can easily implement a tracking mechanism and build a customized reports to analyze the information. And it can also increase the cooperation, because if the team member can easily view and share the information across a cloud-based platform. And the last one is the quality control. As you can imagine, since all documents are stored in one place and in a single format, so everyone accessing the same information, so you can maintain consistency in data, avoid the human error, and have a clear record of any reversions or updates. But however, how to integrate your things to cloud? Since there are so many different devices and they may have different interface and using different protocol, like the sensors, They may RS-232 or RS-485 interface, and using the Modbus protocol or even using the LoRa and BLT, the low power Wi-Fi. So before you start doing the integration, you may consider about correct gateway, or we say the IoT gateway. If the gateway support those interface and protocols, and then you need to design the communication method with the cloud. That means what communication way the cloud server supports, like the MQTT or RESTful API, the most popular cloud agent. And after both issues are cleared, then you just can start to integrate your things to cloud. Okay. This is a simple topology that I create. As you can see, there is a HCB, and it connects with the sensors, PoE camera, speaker, alarm, emergency button, and of course the cloud server. Since the HCB embedded MQTT and the RESTful API, so it can directly communicate with the cloud server and transmit all of the data to the cloud. And as I mentioned, different devices will use different interface and protocols. Like this example, the sensors are using RS485 serial with Modbus protocol, and speaker is audio type. PoE camera is using RTSP transmission. Alarm and emergency button is for DI and DO. Now let's see what should we configure. First of all, you need to configure the serial port for sensors. The sensors we use for the topology is RS485 2-wire type. And the baud rate is 9600. Priority is none, and data bit is 8, and step bit is 1. Of course, if your sensor is using other setting, please just follow your sensor setting, okay? And also, as I mentioned, the sensors we use are support the Modbus protocol. So we also need to set the Modbus tag. Here, we have 3 sensors on our sample topology: the CO2, temperature, and humidity. So we just need to add the name in. And for the slave ID and address, you can find on the sensor. Since different sensors will have different slave ID and address, so please just find the information on the sensors. And we also have an emergency button, which connects to the DI. And when someone is push the button, the DI position will change to high from low and trigger the DO alarm. So here we need to select the DI as high. So just check it. And this one is for the PoE. As the PoE setting, the PoE default setting on the HCB is disabled. So we need to manually enable it and then give the power budget. The maximum PoE power budget for the HCB is 210 watts. After that, we need to enable the PoE mode and then set the powering standard like the 802.3AF, 80, or even BT. And also, the last one is the power budget for each port. Okay. We also need to tell the device, the HCB, where is the cloud server. So we need to provide a server's IP to HCB. And also, as I mentioned, we are using MQTT to communicate with the cloud. So we also need to provide the MQTT published topic here. Please note, the topic should be the same as the cloud server. That means what you set here, the cloud server should be set the same, okay? And the last one is the date and time. This one is very important for the data synchronization. If the time is different with the cloud server, the data may not be able to send to the cloud. So you can manually set the time or use the NTP. Our ThingsMaster Cloud embedded NTP server. So you can just give the cloud server's IP and you will automatically synchronize it with the cloud server to ensure the time will always the same as the cloud server. In addition, if you are using our SCP or our WR device, please don't forget to save the configuration after changing any settings. Otherwise, the setting will be disappeared after device reboot. And after the IoT gateway setting, I mean the SCP setting. So now let's see what should we do on the cloud server. First of all, we need to tell the server what is the IP camera's IP address. And then you can see the video image on the cloud dashboard. So we need to fill the IP address for the PoE camera. And then we also need to provide a speaker address. For this simple topology, this is the SCB's address because the speaker is connected with the SCB. Okay. And SCB is also support AWS and Azure public cloud. So if you are using AWS, first of all, you need to create a thing and give the device name. Like here, the SCB 1200 or 1000 here. And then create the certificate file. The certificate, private key, and the root CA is required for the authentication. After that, we also need to copy the target host link for the SCP to interact with the AWS cloud. So you need to copy this link. And then just paste the link to SCP AWS IoT page and upload the certification files like a root CA, certificate, private key. Later, we just download via the AWS public cloud. And for the Microsoft Azure, the setting actually is almost the same as the AWS. First, we need to do is get the connection string. So we need to go the shared access policies, the left one, and then choose the registry read-write. Then copy the primary key of the connection string. Then paste the primary key string to the Azure Device Explorer and give a portable gateway host name. Then generate the SAS token. It's like here. Okay. After that, go back to our SCB Azure IoT page to give the Azure IoT Hub's path and pass the SAS token. Finally, you also need to upload the root CA. The CA you can download via the Azure website. After we finish above setting, you can see all information on the cloud dashboard. And for the ThingsMaster Cloud, we do support IIoT responsive web design. So you can just use your cell phone or iPad to monitor it, to check it anywhere, anytime. So you can do the real-time video surveillance from the IP camera, real-time sensors value like the CO2, humidity, and the temperature. And also the trend chart for each sensors. And you can use the trend chart's history data for the feature analyze. And you can also set the threshold of each sensors. Excuse me. For example, when the CO2 is over a certain value, the alarm LED will be triggered. As this example, you can see the threshold we set is 1,200. Means when CO2 is over the value, the alarm LED will be triggered to inform the field site people the CO2 is too high. There may something happened, they may need to be checked. And the emergency button alarm. When someone in the field site is push the button, the field site alarm LED will be triggered. And also, during the alarm pushed, it will also send an alarm log to the cloud to inform the administrator, or even you can make an emergency call to the control center for two ways of communication. And when the button is pushed, the icon on the map will change to orange color, so we can also very easily to know the location. If there is any emergency, we can just help to call the 911 or ambulance to reduce the injury. Actually, this function is very, very useful for the smart city or the safe city applications.